Good evening and a warm welcome to the SES webinar on Tech Village, Bangalore. May I now introduce you to the moderator and speakers for today. Let me first introduce you to the moderator, Mr. Hiten Mahimtura, Director, Mahimtura Consultants Private Limited. Hiten, as a Director of Mahimtura Consultants, has over 34 years of experience and has worked on various national and international projects involving detailed structural engineering, conceptual planning, and structural assessment studies. He is a member of PEATA, Bombay, member of Institution of Engineers India, and many more professional bodies. Mr. Mahimtura has many awards on his name and also the chairman of the Steel Day 2019 Experts Committee. Now our speakers, Mr. Anshu Mahajan, Executive Director, RSP Design. Anshu has over 33 years of extensive experience with reputed practices on a wide range of projects. He is a director at RSP India and is responsible for the design of IT parks, commercial and retail, and residential developments. He has worked on some very prestigious projects like Mayantya Business Park, Prestige Tech Park, Embassy Tech Village, etc. Up next, Ms. Shilpa Pattar, Associate RSP India. Shilpa is a graduate from Gogte Institute of Technology and a postgraduate from Architectural Association School of Architecture, London. She is a registered architect with COA. In her extensive 12 years experience as an urban designer and architect in India and internationally, she has worked on a wide range of projects ranging from mixed-use developments to IT campuses, commercial and residential projects. With a keen interest in understanding design methodologies and patterns in nature and urban fabric, she developed strategies into multifunctional architectural environment. Shilpa has been associated with RSP Design India since 2006 as a key member of its design team. Up next, Mr. Jatin Shah, National Director, Colliers International. Jatin is a seasoned real estate professional with over 18 years of experience in India. He has managed the entire aspect of project lifecycle development in multiple projects executed across India and abroad. As National Director, MD and Chairman India Office, and within domain expertise of design, procurement, cost, and overall development, he has collaborated and led teams to provide value-added suggestions and inputs. Sharing his expertise, knowledge, and leadership skills across multiple projects, clients benefited through the suggestions made by Jatin on cost, time, and buildability. Up next, Mr. Hariom Gera, Managing Director, Constructure Designs Private Limited. He has expertise in design and concrete, steel, and composite structures. He has served as principal for many notable buildings and other structures. His passion is sharing enthusiasm with owners, architects, and structural engineers to develop innovative solutions for complex structures involving intricate designs. Requesting all the attendees to please participate in the poll and do write the name of the speaker whom you would like to address the question to during the Q&A session. Also, do subscribe to our YouTube channel, SCS TV, where we are live now and where you could get access to all webinars and steel construction updates. Over to you, Mr. Mahajan.
Yeah, hi, thank you so much. Thanks for the introduction. And I will begin with sharing my screen here. Yeah, so thanks again for the introduction and thanks for inviting us to talk about this particular project. The client brief was very simple. The experience should be retail-like and not typical corporate office. In response to that, the public access to the campus was to be provided devoid of any security. Ground floor level was to be designed given retail experience that's more vibrant, sacralic in nature and with various textures. This approach made the brief an antithesis of corporate park. So reminiscent of old European town squares that houses various activities like borough market, pop-up food stalls, street performances, musical bonanzas, sport and cultural events, mini banquets, as well as informal outdoor Indian bazaars. Old European town key features like clock tower, town squares, sports zones, high streets, outdoor dining, garden spaces were part of our design ideations. Sketches that were to the scale with workable floor plates and areas are displayed here. So the final strategy consisted of 12 building blocks with varying heights, different facade and peripheral buildings were overlooking central building terraces and buzzing activities on ground level as planned. So that's the landscape master plan, capturing all the essence and medieval elements and textures and colors and like activities that we intended to involve. So the site layout and the stats. Located in the ETV campus, Bangalore, the site area is around 14.57 acres and the super built-up area is around 2.4 million square feet, consisting of 12 blocks of varying sizes and height, the maximum number of floors being 6 to 10 floors. The vehicular movement is restricted to the periphery, which is a one-way loop consists of 5 ramps for the employees that enter to the upper basement, and individual building blocks have drop-offs for VIP and specially able on the periphery. The central spaces and space between the building blocks are dedicated to pedestrian movement and various activities along with fire tender movement. All the building blocks are interconnected with steel bridges from 2 floors and above on alternate floors, which was fire requirement and which helps evacuation during fire emergency and creates interesting multi-level movement pattern between the building blocks. Further, I would like to highlight block A, B, and C combined together generates 0.8 million square feet, which was phase 1 of the project, to be completed within 2 years of approved concept stage. Each block floor plate size varies and hence the placement of cores varies. Buildings with comparatively lesser floor plates are holding a corner cores to provide efficient floor plate for office space. The lift cores are built in RCC, fire staircase in RCC, and the central stairs in checker plate. The basement area extends to approx 10 acres with 2 levels. Lower basement is around 6 lakh square feet, and the upper basement is approximately 5 lakh square feet. So each grid is 11 meter by 11 meter. It's a typical section showing the bridge connection at alternative floors above second floor, and the 2 basements, and the maximum height of the building is 46.1 meters. These are few visuals of the borough market, of the high street, sports zone, and the overall view.
So this webinar is about steel construction, so we will not take you through the design functionalities here, but we'll talk about why did we adopt steel per se as a construction methodology. And probably Jatin later on, Mr. Hariom will elaborate more on that. But architecturally speaking, because we lost from the signing of about 6 months in finalizing the specifications, finalizing the core, also getting the approval done. And the timeline beyond 24 months was never extended. So it became an exercise with PhD and the structuralists to finish the project in time, and we discussed various systems that can be...
Excuse me, so there's some disturbance and we cannot hear you very clearly.
Can you hear me now?
Yeah, a little better.
So I was just mentioning that since the extension of the time was not granted, so we were forced to have a very pragmatic system which will ease us giving and meeting the timelines with the specific time. So the best approach was to do the basements in RCC with the regular RCC columns, and it would have taken us 4 months to finish that construction, considering the it is a 10 acre of a basement here, but phase 1 is only about 1/3 of it. The strategy was to, as soon as we finished up the podium level, we should have the precast element ready with us to immediately, seamlessly put the structure up on the buildings here. So the final methodology and the strategy was to have the basements with the RCC framework and upper levels to get the columns, which is precast on a steel fabric yard there, brought to the site and erected within no time here. So this was a very, very plus gain in time, about 4 to 5 months, where the steel structure and the superstructure were done in very, very quick time here. So this does give an advantage of 4 to 5 months if somebody wants to know what steel structure does as compared to RCC here. Jatin and Mr. Hariom will also discuss with you what sort of complexity does it bring there actually. And so it becomes more not completely as a steel structure, but becomes more of a hybrid sort of structure, which is much more useful in Indian context here. Three more things which I would like to elaborate when we start doing the steel structure here. There was a challenge when we start doing the facade, because if you can see the overall view here, the whole thing was to be very psychedelic, colorful, and it has to be a bazaar-like sort of thing here. So we could not go ahead with what is called unitized systems here. So we had to have the block work to do the texture paint on the walls here. So those challenges we will discuss later, what sort of challenges when we put steel structure and its compatibility with the RCC as well as the block work here, and what sort of sequence which comes into the picture and where the speed actually goes off here. So far the superstructure were concerned, this concept was actually really pretty well in terms of meeting the deadlines. But when we picked up the core and we picked up the block work here, the wet work actually, whatever advantage we gained was lost from this, because the core, which is right in the corner here, the finishing of that and its connection with the RCC work was to be perfectly timed, but since we did not have that much experience, it was not done. So we spent quite a time correcting those cores and doing the block work here. And another issue which we have faced was the waterproofing, which is also Mr. Hariom will give the solution what should be done when we do the top slab here. The waterproofing sort of very specific requirement for doing a steel structure here, because the expansion of the steel with the deck sleeve and the waterproofing membranes, because of the weather conditioning, does begin to develop cracks and water draining out, and after 2-3 years begins to get cracked here and it begins to show leakages here. Thirdly, we will also like to highlight the firefighting technique should be elaborated, and the cost should be absolutely put it into the budget here, because fire paints are really expensive as compared to the other techniques here, or covering with concrete here. Because advantage with steel gives is that if you have exposed ceiling, we will show the interior shots to you. It does bring a different kind of interior, very spacious as compared to the RCC, where you have the flat slab and there's no character, no texture inside the interiors here, which we'll like to highlight through our video here. We'll show it to you. And lastly, the expansion joint and detailing with the steel RCC should be kept in mind when you're doing this sort of elaborate structure here. And from here, I will just share the interior video and probably ask Jatin to elaborate more on the timelines and the challenges of what we do in a steel, because this is more of a steel webinar here. I just played the video for interior, so have a look at what steel does when we are looking at the interior shots of the steel building. Yeah, just give it. Yeah, these are the finished interiors here. And we will stop where we actually become very clear what steel does actually. These are the finished interiors of the project. Yeah. Yeah. You can see the deck slab here, the beams here. This is what is the typical interior view of a steel structure. the services, the holes are done very neatly. It's a very neat finish here. You can save on the costing, as well as you can give different character to the interior here. The steel beams are visible here, the sprinkler pipes are visible, all services are visible. So this is how the interior should be done, actually not hiding the services here. If any MEP consultant sitting here, you should note down, this is the way the service should be done in a building, all open, but become part of the aesthetics here. Please pay more. So you can see the center status of, it was not the decision taken earlier part of the design, it was designed later on, but so easily this flexibility comes in the steel structure that we can introduce. We don't have to cut any slab, which becomes a very heavy exercise otherwise, and it's a very cumbersome thing. In steel, it's easily adaptable. We can introduce any element, we can introduce any toilet. Those things, steel structure actually gives a lot of flexibility there. And I'll just finish the video and hand over to Jatin in terms of logistics and everything. Please take over from here. I think we have finished with the architectural introduction here.
Thank you so much. I'll stop sharing the screen now.
Yeah.
Thank you, Shilpa and Anshu for the wonderful presentation. And now we request Jatin to give us his presentation, his part of the project management presentation. Or over to you, Anshu. Over to you, Jatin, please.
Jatin, sir, we cannot hear you.
Your voice is not audible.
Am I audible now?
Perfect.
Yes, sir.
Yeah, I'm sorry. I was on mute. Thank you, Anshu, for giving us a good overview on the architectural background of this development. I would quickly run through you, as Anshu was also mentioning during his discussion, about what went through as a design process or the decision-making process to bring and decide on this kind of structure to be picked up. I'll cover, though Anshu has already covered about project overview, but just to keep you all updated about, it was a 14.5 acre site with a 2.9 million square feet of about development and about 2 million square feet of sale area. There were about 12 blocks. You can see all those 12 blocks outlined here. Some of them were varying heights, but I think the maximum height was about G+10 with 2 basements. The target here was to complete the civil in 16 months and hand over the entire facility with the fitted out spaces in 24 months of time. It was a LEED Gold certified building. Without getting into too much on architectural parameters, but while deciding on the type of the structure, the key parameters which were driving the decision were what were the timelines. Okay, the stakeholders, as Anshu mentioned, there were stringent timelines which were to be adhered to. The requirement of manpower to manage a project of this scale, whether we have various systems which are available in the country today, and which system to adopt to for this achieving this kind of timeline, and the related manpower was another issue. Logistics played a very clear role. Logistics of bringing in material, logistics of movement of manpower, logistics of movement of machinery. These were some of the criteria which are looked into it. Specifically, the designs were also driven by achieving the number of car parks, which is a mandatory requirement to achieve those kind of design issues, complying to the codes, etc. These were other major design parameters also which were taken care of. And above all, when you elaborate, when we evaluate a number of systems, we also have to look into it, what kind of vendor profiles which we have in the country today, who are the capable vendors of doing this kind of project, and how many of them are available for executing such kind of projects. I'll move to the next slide. Uh, These were the various systems which were explored. One was a conventional RCC system. You can see it's all completely RCC construction. The other option was a composite steel structure, right from the the foundation levels going up to the terrace, where we have MS structure with deck sheets. Obviously, we all know about it. The third option which was explored was an RCC basement, means the basement which is going below the ground completely in RCC and above ground in steel structure. Why was this option explored? I will explain you in the next slide. And obviously the fourth option which was also evaluated was precast structure for the entire campus. Good. On the decision making, the key criteria as explained to you was the timeline. Now, conventionally in an RCC structure, we would have finished this structure in about in 23 or 24 odd months, taking an average slab to slab cycle of about 20 to 25 days. In case of a composite steel structure, we could have achieved it in 19 months. And in case of a precast structure, we could have done it in about 21 months. An RCC basement, we were able to do it in 16 months because this was an atypical situation where the excavation for the project was completed. We were ready to start the foundations, and that's where the I would say that between the stakeholder and the developer, the discussions were going on whether to start or whether to commence, or the final level of discussions which are happening. The moment we got a go ahead, by that time our RCC drawings for the basements were kind of ready. So we decided that we will not wait for the steel structure design to come up. We will take advantage of site being excavated, and we will go ahead with the RCC works for the basement. And by that time, we will complete our design works, and then we will start taking up the steel structure as soon as our podium slabs are ready. So this decision led us to a constrained timeline where we took advantage of the situation, and by that we were able to finish the project in about civil structure in about 16 months. That was a target which we had set it, and overall completion of the project with all the services and facade getting into this realistic timeline, which was meeting with the tenant requirement as well. So this was one of the important criteria, which was the timeline based on which this decision was taken. Moving to the next slide, some hard data. I just want to project to you the certain hard data that what helped us to further, plan the entire logistics or entire project was there was approximately 12,000 metric ton of structural steel to be used in this project. The reinforcement was about 11,000 metric ton for a 3 million square feet. So you can do your divisions and you can work out the consumptions which we had arrived at it. Concrete, which was to be poured for this kind of structure, was 130,000 cubic meter. Had it been RCC structure, it would have been much more. So, these were the certain parameters based on which we evaluated what kind of equipments or what kind of machinery is required, the skilled manpower requirement, the laydown areas for the steel structure, looking at the a planning aspect that at no point of time the site should be deprived of material. It was not a just-in-time situation also, because we also had to cater to what happens, what in case there is a breakdown or in case there is some situation. So we always had to plan for at least a minimum of 7 days of material stacking at site to see to it that there is no disruption happening during the construction. The mechanization, which included the cranes, the hydras, the mobile crane, the stack fixing machines, the bolt connection, which were required, which cannot be done manually, the level of quality checks, which is needed both at the state of factory where the production is happening and at site, and of course, emphasis on what kind of fire treatment which the structure would require to comply with the codes which are important. So this are certain hard data which I'm just projecting to you for everyone here. We're close to about 250 participants on this, and just to give an idea on what went through while designing, while planning this project out on papers. I just want to run through you with the quick logistics, the way this was handled at site. We had an entry point. We had a dedicated entry for the batching plant material movement because of the capacity of the concrete which was required on day in and day out. There was a pouring of concrete which was happening. We had planned a dedicated exit. So at no point of time there was a cross, or there was an any stoppage. There was always a free movement happening. So this was how it was all planned out. And reaching to the project site itself, we had planned for tire cleanings. There was barricadings which was set up. We had planned for three batching plants, but eventually we ended up having one of 60 cubic meter plant and one of 30 cubic meter plant at this site. So the vehicles materials could just move in and then come out of this campus. We had shuttering and other storage yards designated for the RCC works, which was going to go in the basements. We had a laid down area of about close to 2.5 acre for the structural steel, which was supposed to come, and it was supposed to be unloaded, as I mentioned to you, a 7-day stockpile here. Apart from that, we had about close to 12 tower cranes. In addition to a mobile hydra crane of a very high capacity, which was about a 60 metric ton capacity. In addition to that, we had 3 hydras to lift the steels from one location to another location and to help to transport and lift up to the required location. The one big point which I missed out, that which Mr. Hariom will also cover, that for the first time we experimented, or we have never done an M80 grade of concrete. This was used for the first time in this campus, in this building, to obviously help the structural designers, and bring in the efficiencies which are required for the project. We had a lot of confidence in our design team, and that's how we proceeded with having this kind of, I would say, a mixed structure, which is RCC in the basement and composite steel. A very important parameter which helped also to further explain all this to stakeholder was that in upper levels the column sizes were reduced to about 807 and 750 mm, and in abeyance to what you would have eventually had about a 1 meter column had we gone ahead with RCC structure. So the nice video which Anshu and Shilpa showed, it helped to get a better efficiency. That's what we talked about when we talk to the stakeholders in terms of fitting out spaces. Um, uh, Another aspect which helped us in this massive construction was that the quality with the steel structure is far superior when compared to an RCC structure. Obviously, we all know about it. I don't want to get into the details of that, but the precision which is required, the the approach which is required is far better in a steel structure construction when compared to an RCC structure construction. This all helped us quite a lot. uh, we also in this project wanted to not just go ahead with a design. In reality, a load test was conducted at site for the required capacity, which Mr. Hariom can also again cover. And this was with the help of a third-party testing agency. I would mention Civil Aid here, who helped us out in setting up the test beds and taking up the testing physically at site. This all eventually helped us, and we were able to achieve a slab to slab cycle. Though it was planned as a 10-day slab to slab cycle, I would say we were able to achieve a 12-day slab to slab cycle on an average. So these are certain aspects which we went through. We also had Promat and a Berger combination here, which is an UL approved, intumescent paint applicator, who helped us in making sure that this treatment was happening in parallel to the construction which was going on at site. Um, I would show you some kind of project progress photographs. It gives you fairly a good idea about kind of works which was happening in this massive 14-acre project site where every location was, you could see something happening, and every day in one block, either the deck sheet was happening, or columns were getting erected, or foundations were happening, or the concreting was happening above the deck sheet. So the sequencing, the planning, the type of selections which we had eventually helped us a lot to reach to this level. There have been always, in any project when we do, there have been always lesson learned, and just a few aspects of lesson learned, which eventually we can also discuss after Mr. Hariom, finishes his presentation. Provision of sleeves during the design team. You would have seen the video that how neatly the firefighting pipes were actually, by the usage of sleeves, we were able to, take advantage of that height issue. We would also recommend that in future, when a steel structure is being designed for a classic aspect of a BIM consultant, possibly will play a very important role here, because then your coordination aspects are on day one resolved, and it's not left to the site issue. Another aspect of that, it may be recommended to have a second frame to hang the ceilings wherever it is required, or to hang the the services lines, so that the main structure is not disturbed. Fireproofing of the material, you can always use vermiculite, or you can use intumescent, but here in this case we went ahead with intumescent because the client wanted to have an open ceiling plan. Had we gone with vermiculite, it wouldn't have been aesthetically pleasing, so there was an investment made on intumescent paint, and that's how you see those gray and white colors which Shilpa showed on the video. Anshu did also mention about various aspects about block work. And as he was trying to explain, the facade here was a combination of windows and a lot of block work and a lot of plastering element which was coming in here. We have seen that we need to be more diligent about how to use this and integrate this into our system, and so that to avoid the cracks in future, or what kind of grouts which we can use, especially where the areas are touching the steel beams and there is an interface happening between the block work and the steel beam. Primer, whether it's required on the MS sections or not required, it's a debate, but Mr. Hariom can also talk about that. But eventually, whenever a vermiculite applicant or a intumescent applicant wants to use the surface, he has to deprime it. So if the logistics are right, if the material deliveries are right, we can actually possibly avoid the kind of primer which might be required on the project. But that's again a debatable topic, and structural engineers should be able to advise rightly on this. There's a lot of emphasis is required on the requirement of specialized machinery. That's an extremely critical point. Whenever a steel structure has to be done, your machinery requirement has to be planned on spot on, because there can be delays if the machineries are not right, especially the stud fixing machines, which are important because these are critical aspects of it, and also the bolt tightening machines. These two parameters we have learned, and though we were able to upgrade it immediately, but this one point would be important to achieve. Anshu and Shilpa also spoke about facade interface. The kind of facade which a steel structure requires is different from possibly what was planned here. This is another point which we can all delve on, and the designers need to look into it very clearly, so that we don't end up into the situations which we had there. And of course, the waterproofing system, especially the areas which are sunk, they need a specialized treatment, specialized kind of waterproofing system. This waterproofing treatment, be it at terrace level, or be it at the balconies, or be it at the connecting areas where the bridges were planned, or the toilets, need a specific treatment. So these are certain aspects which are critical for a project which is going to happen on an MS, such kind of structure. I would also possibly, I don't have the floor layout here, but Shilpa showed the, I will try to see if I have the layout. No, I don't have, but yeah, you can see that at this corners, we had the lift course, and these were not centralized lift course because of the way the buildings were laid out. So in fact, you can see the central building where one corner, the white color on the top, you can see the lift machine rooms, and the one corner there are staircases which are being planned out. So in this project, we had lift cores and the columns happening in MS structure. The staircases eventually were, we had the columns and the stinger beams coming in MS, but we also used precast here because the contractor was more comfortable having that there. This kind of arrangement, possibly structural consultant is happy about because it kind of helps them. But again, I will leave it to Mr. Hariom to take it forward. And yeah, I will be open to any kind of questions which I'll be happy to answer them. Over to you, Mr. Hariomji.
Thank you, Jatinji.
Thank you, Jatin. Hariom, you can start your structural presentation.
Hello, good evening, everybody. Mr. Anshu and Mr. Jatin is talking about the detail. So I am just going with the slightly faster side. Hello. Hello.
Yeah, Hariom ji, your voice is audible.
Yeah, please go ahead. Please go ahead.
Actually, this is this presentation is not working.
Is your presentation freeze? Then what you can do is you can unshare and share again.
No. Okay. No.
Okay. Great.
Okay. Just project brief is already discussed by Mr. Jatin as well as Mr. Anshu. Now I am discussing about the structure of the project. The structural system we have taken, because this is the building in the zone 2, we have taken OMRF ductile shear wall. And for one building, we have tried with the ordinary movement resisting frame, steel bracing, and the ductile shear wall. And the primary frame is the grade, typically grade is 11 by 11 meter, and this 11 meter is divided into a 3. So this is the typical span of the deck sheeting is 3.7 meter. The approximately consumption of the structural steel is 9,900 metric ton, and the reinforcement approximate 14,000 ton. Any composite construction, there is the divide into a two part. First is the pre-construction activities, and the second is the construction activities. In the pre-construction activities, the main role is the project scheduling. Like I think somebody has asked the question, we have delayed the project 6 months because of the planning. That's where the planning is the leading role of the composite or the steel construction. And design as well as the material selection also going with the speed. This is the material selection, like Mr. Anshu and Mr. Jatin is also said that this is the facade system is not going with the speed with the steel. That's why after the flip card, we have advised to the client. The generally you will choose the facade as a facade glass, मतलब glass structural, मतलब glass facade, or any precast system who can match the speed with the steel construction. Third thing is the fabrication drawing. After design, we have go to the fabrication drawing. Fabrication drawing goes to the fabrication. There's the fabrication is the very critical role, because in the fabrication we require at least 3 months to get the material at the site. So the project planning is properly required. That's why we have started this project very immediately, and we have designed the project within the design and the build the project within the 16 months, because we don't have a time of the lacking of 3 months. So that's why we have started the RCC construction up to the ground floor, and above first floor to terrace we have started our steel construction. In the fabrication, there is the more important thing. We require the inspections also, inspections, machining, testing as well. First, we can start with the raw material inspection. The developer, this fabricator should develop the MTR of the material. In the MTR, they have checked material heat number, material grade, material dimension, mechanical and the chemical properties. And raw material inspection we can do by the visual inspections also. After the raw material inspection, we can go to the fabrication. In the raw material, there is the one thing is more important. If the raw material is the stacking outside the factory, outside the factory for 6 to 7 months, so you can change the scaling is not started for that material. If the scaling is started for that material, so you can start the fabrication with the any kind of cleaning, surface cleaning, like shot blasting, sand blasting, power by mechanical tool, and by mechanical tool. Then you can go to the fabrication. So in the fabrication machining, after fabrication, you require CNC machine for the drilling, cutting, and after the drilling cutting machine, then you can go to the robotic welding machine. Robotic welding machine is required for the speed of the project. This this tech village project we want to complete within a 16 months. So we required the 9,900 metric ton material within a 6 to 7 months only. That's why our project schedule to be arrived. Third, when when this fabrication has done, this fabricated material go to the painting yard. The painting is required or not, primer is required or not, this is depending upon your consultant. Whatever they have suggested, they have recommended, so you can go with that. For fabrication, the accessories also required, welding and the electrode. Electrode also very confusing thing. We can choose the electrode with the whatever we have used the grade of material. And the last is the dispatch. For the dispatch, this is a very important thing for the project. Sometimes our project is typical from the first or second floor, and the vendor, this is a fabricator wants sometimes the beam or column is the similar to the ground to 10th floor. So sometimes the fabricator is fabricate the material with the same material. Suppose we want the fabricated material at site for the first floor. They have sent the 25% material of the first floor, 25% material of the second, and 25% material of the up to terrace. So therefore, this is our total programming due to dispatching is mismatch. So that we have planned the dispatch plan also and send it to the fabricator. This is our dispatch plan. This is we can even phase where we can divide the phases into a plan, so that the whatever the material have fabricated and whatever the we have erected, the both dispatch and the receive procedure should be matched. And in the construction activities, we can, first thing is the material stacking. Mm, when we are receiving the material, we can material stacking is also part of the planning. Sometimes the fabricator has dispatched the material for the lower floor first and the upper floor in later on. Then we can stack the material, lower floor material we can stack up to in the lower side, and the higher floor material we can uh, stack at the upper side. Then when the time of erection, then we can looking for where our material, so that this material stacking planning is also be required for the speed of the fast. Again, this is the quality check. When we receive the material at the site, we can start the inspection. We can start the inspection also. First, this is the visual inspection. Then we can check the dimensioning, dimension check. Then we can check the welding thicknesses. We can check the bolting length, bolting dimension. Then go to the and some non-destructive testing we can done at the site, like magnetic particle test, dye penetration test, ultrasonic test, or radiographic test. This is go with the according to go with the your QAP, quality approved plan, and this testing is required for the quality purpose. When then after the checking of the quality, we can go with we can go to the erection. With the erection, first part is the planning of the cranes. Already Mr. Jatin is already explained the 12 cranes and the one mobile crane we have used in the Flipkart project. Tools like stud welding machines and the bolting tightening machines. Then we required the bolt shear connector, and after the erection of the building, we can survey of the building like a alignment also. After the construction erection of the building, we can start the coating at the site. Coating, intumescent coating, whatever the intumescent coating is, two type of the intumescent coating we can explain later. This is the master layout of the total Embassy Tech Village Parcel 5. There is a total 12 towers. G started from G+1 to G+12. This is the first floor typical arrangement. And we have started the steel construction from first floor, not a basement. Up to the basement, we have used the flat slab concrete construction. This is the approximate basement size is 280 by 280 meter. This is total single basement without expansion joint, and there is no leakage after the construction. And in the 280 by 280 meter RCC construction, we have eliminated the shrinkage, initial shrinkage by providing the shrinkage step, and for final shrinkage, we have increased the reinforcement for the final shrinkage. There is a 40 ton bearing. The bearing capacity of this project is 40 tons. So almost isolated footing is coming for the total project, because project height is maximum height is 2 basement G+11 story. The combined footing and the isolated footing we have used. Then the material of the grade we can use concrete grade. We have used M30 to M80. M30 we are using for the deck slab, and the M80 generally we are using for the encasing of the column. Due to M80, we have reduced the size of the column is around 750 to 750 by 750. Steel grade, we
Mr.
have
Hariom,
used.
Mr.
Yeah,
Hariom, so you'll
yeah,
have
yeah.
to speed up a little. We are short of
Sure,
time.
sure, sure,
Yeah.
sure. Steel, grade of steel is 450 here. Reinforcement grade is almost 500. Deck sheet is 350 grade. Bolt is we have used 8.8 grade, and the stud is ultimate tensile stress is for 450. And after completion of this project, because the MSc is doing this project is first time, that they want a more confidence on it. So they want to test the one slab for the original loading. Whatever the final loading, we have tested the slab after the 28 days of concreting. We have, and the everything is going with the as per the code. Whatever the recovery, whatever the deflection, everything is going with the control. That's why the client is confident of that. This is the typical tower of one tower. This is the tower B framing. In this we have placed the column 11 by 11, and the place the beam is place the beam, two beams in the each grid, and we are staggering the beam. One grade we have vertical, and the second grade we have going with the horizontal. Third grade again vertical. Fourth grade we have then horizontal. By this is the the load on the primary beam is equal in the both direction. That's why the depth of the primary beam and the secondary beam is the coming similar. And this is there the core wall in the corner. This is the minimum core wall is required by ductile shear wall for the lateral resisting system. This is the tower D programming. This is the incline that I am showing because there is an incline in the plant. We can go with the steel also, any type of the framing. This is the block F framing. This is also where this is the incline. We can use this. This is IJ block framing, and in this we don't have so much of the shear wall. And as per if you are seen before that, not much of the shear wall. That's why we have placing the bracing here, bracing at the corner to control the drift as well as the deflection. This plan is showing the typical layout of the sleeves for the services. We have given the 5 opening in the one beam for the every services like firefighting, cabling, everything. This is the sleeves in, we have planned the sleeves in the both direction and the same length. This is the typical layout of the opening. There is the 1, 2, 3, 4, 5 plan, and we are staggering this opening for there is no overlapping is there to avoid the overlapping. This is typical section of the column splice. We have started the column from the ground floor, and we didn't give the typical connection of the base plate. We have our steel column is started from first floor, and we have embedded this steel column in the ground floor column till where our force is transferred. This force is in the column is transferred through the bond stress as well as shear connection. This is typical detail of our composite column.
Hariom ji, you got only 5 minutes more.
Okay, sir. Not an issue. This is the electrode classification. Electrode classification generally confused in the market. This is a frequently asked question: which electrode we have used. This is we have shown as per the AWS classification. This E represent electrode. This second digit is represent which is the number multiplied by 0 or multiplied by 10. This gives you a KSI value. Third is the position. Fourth is the flux type. Generally E7018, like we can use this. 7018 means 70 kci is the strength of the material. and the electrode we are using 1.2 times of the yield strength of parent material. This is a composite deck sheet, different type of the composite deck, but we have used the Jindal TR60 composite deck. It is easily available in India. This deck sheet over the concrete 150 mm, it gives you a 2 over 3 over 5 over 4 over 5 rating, and they have give the design based on the BS 476 or UL section. After the decking, we can install this shear stud by the stud welding machine. This is a typical stud we have used. This is a stud we have used by the stud welding machine. Then we can going with the installation of the concrete. With the installation of the concrete, sometimes the error has done at the site. They are pouring the concrete. They are create a lump of concrete at the one location. Due to lump of that concrete, sometimes the deflection coming under the deck sheet. So you can ensure the concreting mass of the concrete. You cannot store the mass of the concrete at the one location to avoid the deflection in deck sheet. Then you have coming with this crane. There is a number of cranes are available in the market. We have used for Flipkart the one mobile crane and the 12 tower crane. And for high-rise structure, we are using the crawler crane. This is the quality. This is the ferrule of the stud. This ferrule is required for the flood. The welding pool is collected there. This is the typical photograph for welding the plate. This is the preheating required for the avoid any bending at the side or lose the strength of the material of the weld. Now we can start some site photograph. This is the ground floor slab, and this column is cast up. Height of the ground floor is around 5 meters. My steel column is started from after 2.5 meters from the ground floor. This is the typical splice detail. Generally, we have placed the splices at the 1.25 meter due to any labor can do easily easily tightening over there. This is a photograph. This is typically movement design. We have designed this movement as a ordinary movement resisting frame. This is my end plate is there, and the one stud we have taken from the web, and my end plate is stick on this web, and we have connected and we have bolted their bolt there. This is the ground floor. There is a typical sleeve layout.
Hariom, can you make the concluding remarks, please?
Yeah, sure, sir, sure. This is only 2-3 minutes, sir. Only 2-3 photograph.
Okay.
This is a junction of the RCC column plus the steel beam there. This is the stud is over the beam. This is the placement of the reinforcement. We required only top mesh for deck sheet. Only for bottom mesh, the deck sheet gives the sagging moment capacity. So we required only for the hogging moment capacity. And this reinforcement is required for the fire rating also. This is the stacking of the material with the grid size, which is the grid, which column is at which grid. We are checking, we are lifting this, lifting the beam or column by the crane. This is the typical junction from the movement connection, their movement connection. This is the again movement connection. This is the typical detail of the movement connection. This is column. In the both side, we have done the movement connection. This is general. This is stud welding machine at the side. This is a simple connection. This is a almost completed building. This is a, I think this we have taken from the B block side. This is a picture created by the architect, and this is the final, the campus after the completion. Thank you. Thank you, Matthew. Any question?
Thank you, Hariom. Thank you very much. I think, Andrea, you want to say something before we start the Q&A sessions?
Yes, sir. Requesting all the attendees to please participate in the poll and glance through the latest interactive issue of SSMB magazine, link to which will be available in the chat box. Also, do write your feedback to edit@mxbm.in. Thank you, sir.
Okay, I'd like to start with the Q&A. The first question, I think, was given to Anshu and Shilpa. What kind of fire protections are taken from architecture point of view, like fire curtains, sprinklers, and form which code fire protections parameters are considered? Anshu, can you answer this regarding the fire protection?
Yeah, there are three things which are considered. First, all the drawings are approved by the Bangalore Fire Development Authority, so they have their own codal thing. And secondly, it is a sprinkler building, and where we have the cutouts, we have put the fire curtains there to comply with the fire regulations here.
Okay, fine. And another question, I think, which is more directed to you, Anshu, was that what is the reason why this 11 by 11 meter grid was chosen?
I think it's a very valid question. So two reasons, sir. The genesis of 11 meter grid comes from the parking. We have a car size which is 2.5 meter by 5 meters. If you want to do a very efficient car parking and a driveway of 5 meters, and the column size is 1 meter. So you can get 4 cars, a 5 meter driveway, and a column size of 1 meter. So that is why the efficient use of the parking, which is the primary concern of all the developers and the tenants here, to get very efficient car parking. But at the same time, when the same grid is translated to the upper levels, and if you do the workstation, which are even 5 feet by 5 feet or 4 feet by 4 feet, or somewhere 6 feet by 6 feet, the arrangement of 11 meter gives you more flexibility in terms, which is very efficient in terms of layout. And thirdly, when you do a RCC structure, which is primary, the 11 meter grid is the maximum where the stresses and all the things can be done. After that, it becomes very stressful for the beam sizes increase, which do not give enough sufficient height to the slabs and the beams here. So 11 meter is the more rational grid we have achieved so far.
Okay, great. That sounds good. And another question which I wanted to ask you, Anshu, is that from this project, what did you learn from the architectural perspective? What was the take home? What are the do's and don'ts? Because this is a composite building, basically. Yes. And it's little different from how you approach another regular RCC building. So from the interior point of view, from the architectural point of view, what are the take homes which you like to tell all the participants and the attendees, that architects also, how should they, what did you get, experience from it?
There are three direct influences when we start doing experiment with the hybrid structure. One is that it should be designed earlier that it is a steel structure or a RCC structure. So when you sit with the structure engineer and other services consultants, it's better that you have all this clarity beforehand, not convert RCC later into the steel structure, because the load bearing capacity of RCC is very, very different from the steel here. And it'll be easier if you decide in the forefront that this is a steel structure, and the core systems and other systems will be designed in a very different way. That is one lesson you should learn. It's the flexibility actually in a structure system seems a very good thing, but eventually it's not a very good thing to do. So that is one lesson we learned. Have a clarity in the beginning that this is a steel structure. Secondly, the facade system which Jatin also highlighted, I also highlighted, it should be unitized system there. So you pick up the speed, you pick up the quality of workmanship, it comes there and you fix it there and becomes a very nice building there. Thirdly, please have as much what is called dry work inside the building, so make it lightweight here. Don't have too many wet works that can delay your construction, because then you're involving two types of system. One is we're talking of precast, highly sophisticated system, the steel being come, they do fixing everything there. But when you go to the wet work, the labor is coming there and they're doing the block work there, then they're cutting, then they're doing plastering, and then they're doing painting there.
Right. Yeah. So basically, you lose the purpose of the speed which you are getting for the structural steel framework, because you got to do a lot of wet. So you need to use more of the dry cladding, the drier working
Yes.
procedures.
Yes,
Great,
and lastly,
great.
the waterproofing, sir, that waterproofing should also be, the suggestion should come from the structural engineer, and that should be absolutely adopted, because if you don't take a specialist hearing from this on terms of waterproofing, the building will cause you later a lot of trouble. As you know, waterproofing leakages are not easy to fix once the building is in occupation here. So
yeah, that's very true.
you should have, they take the opinion of the specialist. I know Mr. Hariom is smiling here, but that's the way it should be done actually. These are the four primarily should be taken as the four lessons we learned very specifically.
Okay, great. Thank you, Anshu. Jatin, we'll just go to you now for a few questions which have come on your on for you. What are the challenges in precast construction in Indian scenario? Is this technology? I think you had mentioned that you had also taken an option on precast.
Yes.
So what was the reason you found it, this composite was feasible, more feasible, and you went ahead with it? I think that is what was, I think the question actually targeted for.
So just to take a holistic view on this, the precast in India is developing. I would not say that we have a problem with the precast systems, but the kind of organized companies which are doing precast and which have the capability of doing a precast structure of this nature or this size is limited, right? Whereas in comparison with the steel structure designs or the steel structure execution companies, we had options at that point of time. Obviously with RCC, we had multiple options. Looking at the timelines which we were evaluated and the kind of the restraint which we had on the delivery, because that was key of this deal, we went ahead with this what you call mixed system of having an RCC structure below ground and a MS structure above ground. Yes, we indeed used certain elements which were staircases in precast. So I would not say that precast has no takers or no buyers. Precast is a system which is being adopted. We have been in fact used one of with RSP in another building in the same campus, which is a complete precast. So but at that point of time, the decision was more on time driven rather than on, and of course the time vendor pool which was available.
Okay, fine. Thank you for that. And there is one more question is they have asked is that what form of contract was adopted and how many contractors were on the project? What software was used for the project construction management? That is the software for managing the and how did you avoid dispute with contractors and subcontractors?
Okay, so the projects are always done on relationships and not on disputes. So I would first start with that, and it's more important that we have okay, from a contracting perspective, we do really need to have right clauses in the contract so that, and the scope is very clearly well explained before even a contract is executed, so that there are no ambiguities about it. At the contract stage, also it is important that as much clarity is given on the specification and on the level of drawings which you're talking about. Primarily, this was a package-driven contract on the overall project. If you look at it, it was divided into multiple contracts with specialist grade A vendors being on the project because of the kind of volume of work. I explained in my slide the kind of tonnage of steel which was required to be procured. That itself was a huge planning required for that. Apart from that, imagine the square meters of glass which was going on this building, or the lengths of pipes which are supposed to be executed. So proper contracting strategies were evolved. There were, I would say, about 40 or 50 grade A contractors who were working, because not all 12 blocks were given to all the services vendors. They were subdivided between various vendors. We had options to back one towards another. When it comes to specifically this contract on the structural steel, it was on a what you call a rupees per square feet contract, from the very reason that the risk of it was a design and build contract. It was a rupees per square feet contract. The very reason that we wanted to see to it that the risk of any cost escalation, if it's a link to a tonnage, variation, is being passed on back to the contractor, and that risk doesn't remains with the developer. And accordingly, the contractual conditions were elaborated after a good amount of internal discussions, and it was taken up to the next level. And with the help of the peer review consultant, we were able to ensure that the designs which are coming out from Hariomji's office, everything was reviewed properly, checked properly, and then only allowance was given to execute the contract. So these were all inbuilt as what you call performance-based evaluation strategies for the contract executions. So
that was a very, 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 very nice way of doing it, basically. And the execution was done must have been done with the targets of the cost in mind always.
Yeah. Cost always is an important parameter.
Yeah.
Especially in this project, it was. So
keep a control on it. Yeah. And another thing was that we wanted to know that what are the parameters you would like to put for a contractor if you're doing this type of work, this composite type of work. What are the parameters you would put in the tender to make sure this? Because what happens is that you can either have a contract with a concrete contractor, and then either he subs it to a steel contractor. So you have one guy you deal with. He does the concrete and the steel. So it's a one-point responsibility. Or you would split it up and and manage it separately with each contractor.
So, sir, just to answer you, our initial, experiences has been not to split between a RCC vendor and a steel structure. It's always important that when specifically you are integrating the entire system together, and it's one structure which is going to talk about. So in a DNB contract, it should be one person who should be taking the responsibility of the entire structure and the execution also. Okay. Yes, we could have possibly got an advantage by going to a steel guy directly and placing a direct order with them. But eventually, in the country today, also the steel structure companies are still relying on RCC vendors to provide the cranes or the mechanical systems to ensure that erections happen on time. They can possibly only provide a skilled manpower for supervision, right, or execution.
Right.
The responsibility of tying up the entire both the systems together. So that's why we ensured that this remains with one vendor, and we have executed in other projects as well, where we have negotiated the rates directly with the steel suppliers, but ultimately put it across under the main person, main contractor. And believe me, that model always works better and is much neater way of executing a project like this.
Great. Last question I want to ask you was what is your biggest takeaway from this entire building perspective of this structure, like of a composite structure?
Biggest takeaway I would say is learning. We learned a lot with the involvement of all the stakeholders. It was a project which was demonstrated to everyone involved that how it can be executed in a properly planned manner. Don't rush to a execution, just plan it properly, involve every stakeholder, be it an architect or be it services consultants, and see to it that it's designed well, executed well. Point also is that there were various lesson learned while executing the project, which we have taken those as something which we learn at the end of every project and implement in the next project. So with help of the designers and especially RSP here, we have done subsequent steel structures also at the design table, and which are some of them are on the execution stage. All those design learns have been transformed here. Might be from the height perspective, might be even looking at that around AHUs.
Yeah.
The height of the beams are restricted to see to it that the ducts which are coming out of the AHUs are also planned properly, having a BIM consultant early on the board, etc. So yes, these are my big takeaways. Plus, from a services perspective, you need to plan for special hangars to see to it that services are being hanged properly, and there's a close coordination with the structural consultant also involved in that. The end glazing, the end system is important from a glazing perspective. The slabs needs to behave, the deck sheets need to behave properly at the end areas. That's one area which we have also implemented on as a check. Apart waterproofing, Anshu has been speaking quite a lot on that. So maybe we need to take all those points also.
Yeah, definitely. Thank you, Jatin. Hariom, I think the main questions which are being coming is on more on the technical side would be being Bangalore being zone 2, why did you go for ductile shear wall?
Actually, for ductile, we are generally working in the zone 4, zone 5, and by the ductile shear wall, we are placing the some ductility in the building. Okay, so that the any time of the uptake or the any time of the lateral load, the failure become a ductile, not should be a brittle. That's why we have always go with the ductile shear wall.
I fully agree. It's a good practice to do
Yes.
that, to have that, because you have some ductility in the building, and it can, because nowadays you have freak incidents, earthquake wise and rain wise, there's cloud burst takes place. So you have because of the unusual earthquake forces coming, sometimes you may land up. So every building should be have some ductile inherent
Ductility.
ductility.
Correct.
Now
And
what
we are going with the movement connection also. Some
Yeah.
redundancy is also there.
Yeah, that's what I thought.
Yes. Yeah.
Some redundancies there because you had made some moment connections. Probably you required that. I think because you may be having a lopsided core, so you may require some stiffness on the other side, and you may have to go with your moment frame.
Correct.
Yeah, and what grade steel you have used? There are a lot of questions which have come. What is the type of grade steel you are using, and how you handle the sunken slab in the decking system, and even this fire, you've talked about the fire part. What is the fire rating you all have used, and on what basis? So this is also something which questions have come.
Yeah. Grade of the steel, we have used the 450 grade of the steel, and at that time generally 450 grade is not available in the road section. That's why we are going with the plated section. Okay, so generally in our building at the floor of MSC Tech Village, almost 70% sections are plated section. Only 30% is the rolled section, because there is a JSPL is the vendor for the procurement of the steel. They have given after 4-5 blocks, they have given the rolled section whatever we have given in the plated section. Like my plated section is 180 by 500 by 12 by 8. He has given as a rolled section. So after that, after 4-5 building, they have provided the rolled section also.
Superb. So that was good.
That was good. So now they have taken the more whatever we are using the section in the 11 by 11, 8 by 8 by 8. They have generally rolled their section at the grade whatever you want.
Okay.
Second question is the sunken area. Sunken area, we have weld a plate whatever you want. Suppose you require the 100 mm sunken is 100 mm sunken is the toilet area, and the 150 is this. So we can plate it the flange at the middle height of the beam, and place the deck sheet on that welded plate, and we have handled the sunken area by this method. Third question is
by putting an angle over there, I think so.
Angle or plate, whatever you want.
Yeah.
By putting an angle or plate. And this third is the fire rating. The fire rating issue is the very good question. This for for this embassy tech village, we have used for the 2-hour fire rating as a type 2 building. Generally, internationally, maximum fire rating is the 2 hours. In our Indian code, in our Indian code, the maximum fire rating is the 4 hours. By the encasing of the column, it gives you a 4-hour fire rating as well. Okay. And for the slab thickness of the 150 mm with the minimum reinforcement gives you a 2-hour fire rating. If you increase the reinforcement, then you can achieve the fire rating up to the 4 hours. Third is the beam. In the beam we have a two type of the fire coating material. First is the intumescent paint, and second is intumescent coating. The intumescent paint we have used for this embassy tech village, and this is the approximate thickness. Diaphragm thickness is coming 3000 micron. And the other hand, we can use the intumescent coating also. This is the coating is the vermiculite based coating. This is also a two type of the coating. One is the gypsum based, one is the cement based. We prefer cement based for the higher strength and the higher bond strength. And it gives you a whatever rating you require. Suppose that you are required 2-hour rating, you required thickness is 15 mm, 3-hour required is the 20 mm. So you can increase the thickness of the vermiculite, increase the fire rating. But nowadays I learned from the project, some of the project. So then now the last 2 years I have given the minimum thickness of vermiculite coating. We have generally recommended 20 mm minimum thickness for the fire coating for vermiculite. And the whatever this intumescent paint also, this is the whatever the US the US certified or the BS 475, BS 476, whatever they have given, we are going with that.
Okay. And now the famous question is, how did you do the waterproofing? What are the different details you need to specifically do for a decking system where there's a linear expansion contraction because of the steel and the concrete?
Yes, yes. This is a very good question.
Because this is one question everyone wants to ask.
Yes. Actually, the waterproofing point of view, because generally we are using the waterproofing stick to the slab. Okay, like some type of the cementitious base, sometimes of the PU base, something like this. In when you are stick the coating stick to your main slab or the main primary member, there is a vibration in the floor, so that your waterproofing get damaged, like maybe damaged. Okay, then this is a proper solution of that. You can use the waterproofing, loose laid waterproofing. When your contraction or vibration is there, the no vibration or contraction or expansion to transfer to your waterproofing and the above material also. Loose laid waterproofing, generally we are using TPO, PVC. You can use this kind of the waterproofing to avoid the cracks in the sunken area or the terrace roof also.
Right. So that, and after that, what you need to, because they are all UV protected. So on that, you may not need to put screed on top again, right?
You can avoid the screed, but screed is required for the protecting the waterproofing. Suppose so there is the 1, 2 mm, 2 mm, 2 mm.
You do brickbat copa or you do screed? Which would you prefer?
Whatever you want, whatever you want.
For that slope, for the slope.
For the slope.
Right. Okay. And another famous question is the jointing between brickwork and the steel sections. Basically, what happens because of the movement of the vibration movements, cracking takes place. So you invariably, the joints keep on opening up.
Correct. So at that particular joint, you can place the wire mesh, and after the placing of the wire mesh, you can do the plaster to avoid the crack.
That has worked very well.
Just we have used there. This is worked very well.
Okay. And when you do an external facade, you normally take with glass. But suppose if the architect wants to do brickwork, then how do you handle that? Because suppose you do brickwork and you want to close, you have a different type of elevation features.
Yes.
Yeah.
I mean, this is the same project, na? This is in this project we have done the block work at the periphery. Okay, because there is some punch window and the block work is there. because this is at the one time total 2,700 laborers are at the site, and the out of 2,700, 2,200 labor is using for the block work. By the pace of the steel is the total 12 tower is going on at the peak, and the only 500 labor is required for steel structure, and the 2,200 labors is only going with the block work. So we are now, after this project, we are recommended that the facade you can use the unitized system, system, or any precast system, or any drywall system.
That's what Anshu was also recommending.
Yes.
That is very important.
Yes. We all over team like RSP and Colliers, we are just learn from that project. We cannot use the block work at the periphery in the future.
Okay, but that means there's no way you can use block work at all, or is there some other detail?
You can use if you have a time. If you don't want the pace of the building, then you can use.
Okay. And what is the reason you had to use MAT concrete in this project?
I want to reduce the size of the column.
Okay. So basically that really helped because your cross sections came down and you got the target sizes which the architect wanted.
Yes. We can even place the extra more space in the building.
Okay, great. Carol, do we have any more time on questions? Because there are quite a lot of questions are yet pending.
We have 5 minutes, Hitenji.
We got 5 minutes, so
yes.
Then should we?
Last 3 questions maybe.
Okay. Who was the steel fabricator and erector for this project?
The general contractor is BL Kashyap, and the BL Kashyap is completed project for fabrication to the JSPL. JSPL is the manufacturing of the these plates as well as roll section, and they are the fabricator also. And erection is done by the BL Kashyap own. Okay,
great. There was one question which was directed to Anshu. Basically, it's something to do with the air conditioning system. With ventilation, what have you done with respect to ventilation design and temperature maintenance in the building?
Sir, normally what happens when we do campuses which is of Swiss magnitude, it is always centrally air conditions built there, and the ventilation is provided by putting the exhaust fan on the top roof with the washer units, and is taken care by what is required as a minimum air changes required as per the law here. The steel structure actually doesn't change anything so far the ventilation and other parameters are concerned, to be honest.
It is to do the complex.
Your air conditioning volume goes up because you are not doing false laying, so little bit air conditioning volume go up here. That's the only change.
Great. And for Jatin, what's the cost increment between steel composite and cast in situ RCC construction? This is a very famous question.
It has a various parameters, depending on the height of the building.
Yeah. It varies from project to project. It's nothing standardized. There'll be a range basically.
The range, maybe you can keep at about 250 to about 350 rupees. Depends on soil bearing capacities.
Yeah. There are a lot of factors. Yeah. So basically, there is a cost increase. That is what you're saying. But it varies. Sometimes even you can also go to 150.
Yes.
Maybe you can go to 300 also.
Yeah.
It depends on a lot of factors.
Yeah. But on an average, you can keep that amount of.
Yeah. So what happens is that the overall gain in the cost which you gain while you're doing is the speed. So then as a whole, if you check it out, then it becomes cheaper. If you have been able to gain that speed in construction.
Yeah, Hitenji is now talking like a developer. So it's more about how early we are able to deliver the project and how early my rentals can start. That's a trade-off, basically.
That's a trade-off.
Based on that.
One question you asked whether block work should be used in the steel structure. Sir, if you are using the block work, then it necessarily means you are not looking for a speed up construction. So please go for RCC.
Or today
this is a contradiction for me.
Yeah, today we have various other options also. We have got external grade partitions which are available from various suppliers. Maybe we need to further evaluate based on the lifespan, but that can be one of the options. We can evaluate that as well. Yeah.
So anything, any other things required, Andre? Can you?
Hello.
Hello.
Yes,
Yes.
sir.
Can we have a few more questions, or we need to close down?
Sir, couple of more question and maybe up to you. One or two more question
Yeah.
if you
Okay.
want.
Ariom, basically,
Yeah.
we want to ask you. We talked about a lot about fire retarders and intumescent paint, but we have not discussed anything about the corrosion resistance. So what I was trying to say is that how do you, because though of course Bangalore has a doesn't have that aggressive climate like Bombay, or so, but how do you tackle corrosion, because that is a very predominant thing in the steel.
Good question, sir. Actually, you just we are strict to in the both places in the Bangalore as well as the Bombay also. If we are discussing about the moderate condition, atmosphere environment is the moderate condition. Okay. Generally, we are doing with this type of project, and all the material, all material is manufacturing as per the our requirement. Okay, because we are using the higher grade of the steel, so that the manufacturing is starting the material after getting the order. Okay, so because the because the material production is time lag is not more between the construction and the manufacturing time, so that we can avoid the corrosion resistance paint, because we are using the encased column, because column is already is encased, and the just rusting is there, rusting around 3 4 months. So bond between the concrete and the steel is better when slight rust is there. If the suppose their primer is there, so then there the primer is there, then bond epoxy bond is required before the concreting, because otherwise the bonding between the concrete and the steel is not good. Okay, so then because when you are placing the steel column and the in the time of the casting, you can do the start the bonding. This is not feasible at the site also for the column. And the when the talking about the beam, the beam after the coating of this intumescent paint, the intumescent paint is required in the 3 layers. First layer is the primer. If the project is decided, already decided, the intumescent paint is done, then you can start the material from the factory with the primer. If you are going with the vermiculite, then there is no need to start with the primer. Okay, because when because the rust is there, and the by rusting, this is a vermiculite coating with bond between the vermiculite and the steel is also better when the primer is there. When you are when you are getting the beam with the primer, then you again require the epoxy bond. Any you are increase the activity, and you can even lose the your time also. So this is better when you are doing the concrete as well as vermiculite, then there is no need of the any corrosion resistance. When you are doing with the intumescent paint, so beam you can do the primer with the paint.
Okay, great. Thank you. I think we are need to close down. I want just take a minute. Thank you, everyone. I thank the speakers. They have spent a lot of time and they have made a lot of effort to do this presentation. It was a fantastic presentation. We got an idea how to do composite buildings, and this post-COVID period, there will be a lot more composite buildings coming up because the less labor is required. It's faster, and the resource and the quality is maintained. So because of that, I feel this is a very important webinar we had today, and everyone's got a really good insight of how to handle, how to approach, how to design composite structures. Thank you, and thank you to the attendees and the participants also. Thank you. Without this question answer sessions which you have given, this vibrant question answer session, we wouldn't have been able to make this webinar such a good, successful, and we have got we landed up with nearly about 240 to 245 attendees. So thank you very much. And I stay safe, stay well. And I just hand it over to Amit to
Thank
say the
you,
last
Ji.
words.
Thank you, Hitenji. You were as vibrant as always.
Avni ji, just a second. You can share our email ID to attendees of our Mr. Anshu, Jatin, and my. If any attendee want any question, so they can directly mail to us.
We can certainly will send out
Okay.
the questions to you. I know there are some questions which are still unanswered.
Yeah,
So
yeah.
thank you all the superstars of today's webinar. You guys have done an amazing job, I'll say.
Actually, Avneet, basically all this was such a nice close-knit speakers. All of them. We have worked
Yes.
with RSP. I've worked with Hariom, and I with Jatin Bhai also. And we were part of the peer reviewer team also for this job. So I know this project inside out, and I think you didn't know that. So,
Yeah.
but I turned out to be, you caught me to do for this job.
Okay. So we were fortunate to have you. In fact, excellent. That's why I see a lot of bonding and chemistry between the speaker and the moderator, because all of you are on the same page, I'll say.
Yes.
Okay, quickly ending up today's session, I would like to just quickly share. Andrea, can we have the screen, please? Yes, thank you. So we have a unique presentation, unique webinar coming up next week, which is equally interesting as we had the webinar today. So to give you a brief, we have the Khajuraho Convention Center that will be presented next week. This was a vision of Principal Secretary of Madhya Pradesh to build 1,200 seated capacity convention center to boost a new dimension towards tourism of Khajuraho. Now the structure was unique in many aspects. This ground plus one-story structure had terrace and roof. Along with that, of course, it was done in steel. The flexibility that steel gives helped the designer to have a large spans, and a lot of aesthetics was added to the convention center. Now the convention center, this specific convention center portrays the rich abundance of aura and joy of life, which gives a unique experience to the visitor who are coming to see this convention centers and attending the programs. So this project was designed by Vivek Kishore, who is an architect from Finer Edge Architects, and Mr. Nikhil Sanghvi, CEO of SACPL. So we'd like to invite you all to join us tomorrow to join us next Friday, in fact, next week, for this unique structural. They are going to take us through what went into designing and why they use steel and how the construction went. So all of you, the link is there on the chat box. So please sign in for the next webinar, and we'll look forward to see you same day next week on Friday, 5 p.m. Thank you. Thank you, Anshuji. Thank you, Shilpa.
Thank you.
Thank you, Hitenji, Hariomji,
Jatin. Thank you so much for giving us all this opportunity. Thank you so much.
Wonderful interacting with you. Take care.
Bye-bye.
Bye-bye.